Welcome back to Civil Engineers YouTube channel. In this video lecture, I would like to guide you for 28 feet span of beam steel reinforcement details. If you are working on construction site, if you are studying, so watch this video till the end to know about steel structure design if the span is up to 28 feet. But remember guys, this is for normal residential building. This is for a residential building up to 3-story. As you can see guys, this is a diagram for beam and columns. As you can see guys, the beam is supported by these two columns. One is this column and this is the another column. So first of all, I will tell you the size of column, where column size is 12 inches by 12 inches up to 3-story, and we used here M20 grade concrete, where the ratio is 1:1.5:3. Now I'm talking about the beam span, which is 28 feet. What should be the size of beam and inside steel reinforcement up to 3-story for a residential building? The size of beam is here. Size of beam, which is 12 by 18 inches. Width is 12 inches, depth is 18 inches. Let me create its section. 18 inches depth and width is 12 inches. This is size of beam. Where guys, we already used here M20 grade concrete, which ratio is this one. So therefore guys, the size is 12 by 18 inches. So this is size. And now let me guide you for steel reinforcement, where guys we have tension zone, or you can say bottom. At the bottom of this beam, we used 4 bars where the dia was 16 millimeter. This is very important for you people to know about this. Next guys, remember top portion, or you can say compression zone. So at compression zone, we provided 3 bars and the dia was 16 millimeter. I did already this design for one of my client. Next guys, I did the calculation, so therefore I am not wasting your time to guide you properly. So from where you can take the size of the beam, because in many videos I have already discussed. Okay, so therefore now I am guiding you. The other one guys, side bars. We provided 2 bars, 2 side bars. Okay, so I am guiding you now practically, and the dia was 16 millimeter, but at the distance of L by 3. Now let me guide you in detail for this. If you see guys, this is stirrup, and this beam, this is stirrup, and these are hooks. 1 bar, 2, 3 and 4 at the bottom. 2 are side bars at the top portion, okay, where we provided at the distance of L by 3. What is L by 3? Means span divided by 3. Here you can say, let me make a section. This is L by 3. L divided by 3. Where L divided by 3? Where this is 28 feet. So 28 feet should be divided by 3. So normally you can say this is divided by 3. So normally you can say this is about not 8 feet, 9.5 feet you can say, at the distance of 9.5 feet, or 9 feet 6 inches and 9 feet and 6 inches. So at the distance of 9 feet and 6 inches, we provided these 2 bars, which is called side bars. Okay, so let me guide you properly here. So these are 2 side bars. One is this one, this is the other one. And these are top bars where we have longitudinal bars, and these are bottom bars, which is called tension zone. Tension zone steel reinforcement should be upward to the upward side, bend to the upward side, and the top portion steel reinforcement should be bent to the downward side, which is called development length. it should not be less than 18 inches. These development length should be connected or overlapped with longitudinal bars of the column like this, same like this, and this is development length, where development length should not be less than 18 inches. And this is main longitudinal bar, this is the other one, okay? So you can see the steel reinforcement. So 4 bars at the bottom, 2 at the top, 2 are side bars, guys, you can see, to resist negative bending moment. And also top bars we are providing, or crank bar we are providing. This is very important for you people to know about this. If you require to provide the lapping length, as you know guys, lapping length should not be provided at the beam, especially at the bottom portion of the beam, because this is tension zone. So concrete is weak in tension. So therefore don't provide lapping at the bottom of the beam, because there we have more chances of cracks. So therefore the extra steel rod should be provided at the distance of L/4, because we have negative bending moment. How? Like this. When the load comes on the top of the beam like this, already we are providing the beam, because on the top of the beam we have the structure load, brick masonry or any other structure we can provide on the top of this. So when the load comes on the top of this, so it makes a shape same like this. Look at here. So here we have positive bending moment. Here we have negative bending moment. To resist negative bending moment, provide extra steel rods or crank bar. To resist negative bending moment, provide extra steel rods. To resist positive bending moment, so provide extra steel rods here at the bottom. Instead of overlapping, provide extra steel rods. Okay? If you require to provide the lapping length, lapping is not allowed at the distance of L/3, because here we have also more chances of cracks. So here we should provide extra steel rods. So don't provide here at the bottom. If you require to provide the lapping length, so provide at the top portion, but at the middle. Provide lapping at the distance of L/2, but not at the bottom. But you can provide at the top. So this is the proper way of steel reinforcement, because concrete is weak in compression. Concrete is weak in tension, but it's strong in compression. So therefore in compression zone I provided 3 steel rods, because it's strong in compression. What? Concrete. But it's weak in tension, so therefore we provided 4 steel rods. So therefore we are providing minimum numbers at the top portion and maximum numbers at the bottom portion. The top portion steel reinforcement, the dia can be decreased, but the bottom portion steel reinforcement should be, the dia should be increased, because it's weak in tension. Remember, if you want to build your house and you don't know about the steel structure design, if you are going more than 2-story, so you should hire the structure engineer to give you the structural drawing for the residential building or for commercial building. If you don't have any experience, so don't try this. That's why, because before this you should know about the bearing capacity of soil, the full structure load, and also you should know the wind load, earthquake, maximum loads we have there. So therefore including all these ideas, you can go ahead, otherwise you will face more problems. So guys, this is a short video in which I have guided you for 28 feet span of beam with the size of 12 by 18 inches, 4 bars at the bottom, 16 millimeter, 3 at the top, 16 millimeter, 2 are side bars. Grade of concrete is here M20 grade concrete, where the concrete cover is 1.5 inch, you can say, or normally 40 millimeter. And also the hooks are bent on 135 degree. It should not be provided on 90 degree, but it can easily move from each other. So therefore don't provide on the 90 degree. And also the spacing of the stirrups should be closely placed at the distance of L/4, where we have negative bending moment. And also you can see this side, left side, and also right side. And if you are talking about the middle, are at the distance of L/2, so left and right side you can increase. Suppose I am providing the steel reinforcement or the stirrups, so provide 4 to 6 inches, okay, center to center, and the dia should not be less than 8 millimeter. This is for the stirrups. So 4 at the distance of L/4, you can keep or place 6 inches spacing. After L/4, you will get the good result. Thanks for watching. See you in next video. Goodbye.